My name is Jeff Hara, and this is my presentation on Tree-to-Tree neural networks for semantic parsing, parsing natural language into first-order logic using deep learning. First, I'll try to motivate why I became interested in semantic parsing and how I aim to do something different. For the past few years, I've been working on the John Etchemendy's Open Proof project, which develops software to teach students logic. One exercise that we have the students do is to translate natural languages into logic, which is exactly the task of semantic parsing. I was interested in building a semantic parsing system of my own and deploying it as an educational tool. Now, to the degree that semantic parsing is really just a translation problem, it is actually a perfect use case of encoder-decoder models. Encoder-decoder models have been quite well studied, and here are a few salient examples in research. The tree decoder and tree encoder have been developed in different contexts, but the reason behind them is identical. The authors recognize that natural languages and logical languages are both tree structured, and leveraging this fact can improve performance. The research question that I wanted to ask was, if the source languages and the target languages are both tree structured, then why not use a tree encoder and a tree decoder? For the data, I had access to Stanford Lingo Lab's translation system, which, given a logical form, can generate natural language sentences. I recursively generated logical forms using their defined ontology and sent requests to their server to build out a dataset. My experiments are set up as follows. I wrote implementations for a sequence and tree encoder as well as a sequence and tree decoder. Then I trained each of the four models. The inputs for the sequence encoders is a sequence of indexes where each index corresponds to a word in the source vocabulary. The input for the tree encoder is a little bit more complicated. I used a dependency parser to get a tree structure and fed that directly in as input. This I call the dependency tree, or dep tree. The tree output is simply a logical tree that branches up the predicate or the operator. This I call the first-order logic tree, or fault tree. For some preliminary results, my sequence-to-sequence model, which was meant to be a baseline, unfortunately ended up performing really well. I trained it for 100 epochs, but by 30 to 40, it was figuring out how to make well-formed formulas, and by 50, it was nearly perfect. Interestingly, though, it seemed to struggle the most with getting the parentheses in the right place. This was something that I thought that the tree encoder and tree decoder may have an advantage. For the tree-to-sequence model, it didn't perform as well as far as accuracy, but it seemed to resolve the issue with the parentheses. However, it did also confuse the order of the constants and figuring out which constants go with which predicate. So far, it is hard to say anything too conclusive since the tree decoder trainings are still underway. However, since the dataset is synthetic, it is likely that these models are a little bit too idiosyncratic to the dataset. Over the next week, I would like to spend more time investigating which models struggle with which type of parse rather than focus on the accuracy. Thank you for your time.